energy. Work. When a force acts on a body, it enables the body to move. When we move a body or carry any object, we have to apply a force. In general, we can say that we have done some work. When we play or we carry school bag or we go for a walk, then we are doing some physical work. When we read, write or do work on a computer, we can say we are doing mental work. However, mental work is not recognized as work in physics, though it also needs energy. In physics, work is said to be done when an applied force moves the body through a distance or displacement. Nature of work. Work done can be positive, negative or zero. 1. Positive work done. Work done is positive when a force acts along the direction of motion of the body. Examples. When a rickshaw puller pedals the rickshaw, it moves forward. Work is said to be done. When a door is pushed, it opens and moves forward slightly. Work is said to be done. Some other examples where mechanical work is done are when we move a lawnmower in a lawn, when we kick a football, when a horse pulls a cart, when we climb a staircase, etc. In all these examples, displacement of the object takes place along the direction of force. Hence, positive work is done. 2. Negative work done. Work done can be negative when a force acts opposite to the direction of motion of the body. Example, work done by the force of friction is negative. 3. Zero work done. When a force is applied on a heavy object and it does not move, we can say that no work is done. Example, a boy is applying force on a big log of wood, but it does not move. We can say that work done is zero. Thus, the amount of work done depends upon the following. 1. Force applied on the object. 2. Distance moved, displacement. Work, force applied into displacement, F into d. Thus, work is the product of force and displacement. Do you know? Bees obey the first law of thermodynamics. The total of the heat energy they produce and the work they do is equal to the amount of energy they take in form of food. Measuring work. Consider the following two cases to understand how work is measured. Case 1. Suppose a person A pushes a wooden box to a distance of 10 meters. Another person B pushes the same box to a distance of 20 meters. Which person has done more work? Person B has done more work as the box covered more distance. This shows that work done depends on the distance moved by the body. Case 2. Suppose a person C pushes a box 20 kilograms to a distance of 10 meters. Another person D pushes a bigger box 40 kilograms through the same distance. In this case, person D has done more work than person C because he has to apply more force in displacing a heavier object. This shows that work done depends upon the magnitude of force applied. Unit of work. The unit of work done can be obtained by multiplying the units of force and displacement. In SI system, it can be given as work is equal to F into D is equal to Newton into meter. This product is called Joule, named after the scientist J.P. Joule. When a force of 1 Newton moves a body through a distance of 1 meter, then the work done is said to be 1 joule. 1 joule is equal to 1 Newton meter. The larger unit of work done is kilojoules. 1 kilojoule is equal to 1000 joules. Fact: a television consumes around 120 watts of electric power, while an average human being uses around 400 watts to run. Introduction.
Energy is needed in all steps of life.
It is required for operating machines, for transport, for lighting our homes, cooking food, and for leisure, pleasure. It is difficult to think of an activity without energy. To meet our requirement of energy, we use fuel and electricity. Let us try to find out the primary source of energy and know more about energy. Energy. Capacity to do work is called energy. Energy is measured in terms of work done. Energy is needed to do many physical works and physiological functions like respiration, circulation of blood, digestion, etc. This energy is obtained from the food that you eat. Energy has the unit as that of work. The SI unit of energy is joule. Energy is used in various forms to do work, to provide warmth, and to move goods and people from one place to another. Energy is also used to operate many devices. The electrical energy is used to run washing machines and electric pumps. Heat energy is used to cook food. Mechanical energy is used to move vehicles, etc. Different forms of energy. There are various forms of energy in nature. These are mechanical energy, heat energy, light energy, electrical energy, chemical energy, sound energy, magnetic energy, and atomic energy. Do you know? The world's largest wind generator is in Hawaii. The windmill has two 50 meters long blades on top of a tower 20 stories high. Mechanical energy. The energy possessed by a body due to the state of rest or state of motion is called mechanical energy. The mechanical energy can be divided into two categories. Kinetic energy. You might have observed that a moving cricket ball can push back the stumps. Moving water can generate electricity. A moving hammer can drive a nail into wood. Thus, a moving body is capable of doing work and hence possesses energy. So, the energy of a body due to its motion is called kinetic energy. A moving car, a bullet fired from a gun, a ball thrown by a player are the examples of kinetic energy. The kinetic energy of a body depends on mass, m, and velocity, v, of the body. The formula for kinetic energy is kinetic energy is equal to 1 by 2 mv square. It is clear from the formula that the kinetic energy is directly proportional to the mass of the body and the square of the velocity with which it moves.
Since the kinetic energy of a body is directly proportional to its mass, therefore, if the mass of a body is doubled, then Ke also gets doubled, and if the mass of a body is halved, then its kinetic energy, then its Ke also gets halved, if its velocity remains the same.
Again, if velocity is doubled, its kinetic energy becomes 4 times, as kinetic energy is directly proportional to velocity square. And if the velocity is halved, then its kinetic energy becomes 1/4. Potential energy. The energy possessed by a body due to its position or change in shape is called potential energy. Energy possessed by an object placed at the top of roof, a stretched rubber band, a stretched spring are the examples of potential energy. The potential energy of a body depends upon 1. Mass of the body, 2. Height of the body, 3. Acceleration due to gravity. The formula for potential energy is PE is equal to mgh. Fact: in 1 year, an average house uses 5 times the energy used by all runners in the London Marathon. From the formula PE, is equal to mgh, it is clear that 1. Potential energy is directly proportional to mass of the body. 2. Potential energy is directly proportional to the vertical height up to which the body is lifted. 3. Potential energy is directly proportional to acceleration due to gravity. Gravitational potential energy. It is the energy of an object possesses because of its position in a gravitational field. Consider an object of mass m being lifted through a height h against the force of gravity. Example, if g is the magnitude of gravitational acceleration, we can find the work done by the force. This work done is stored as the gravitational potential energy. That is, W is equal to UG is equal to mgh. UG is equal to mgh.
Energy transformation in common daily life situation.
According to the law of conservation of energy, energy can neither be created nor destroyed, but it can be transformed from one form to the other. The change of one form of energy into another form of energy is known as transformation of energy. Example, when a body is released from a height, then its potential energy is gradually transformed into kinetic energy. The reverse happens when a body is thrown upwards. The kinetic energy of the body is gradually transformed into potential energy. More examples. 1. In electric bulb, electrical energy is converted into light and heat energy. 2. Water falls from a height on the earth. In this case, the potential energy of water is converted into kinetic energy. On striking the ground, it also produces heat and sound energy. 3. When we hammer a nail, the mechanical energy is converted into heat energy. 4. Electrical energy is converted into magnetic energy with the help of an electromagnet. 5. In an electric fan, the electric energy is converted into mechanical energy. Difference between energy and power. Energy, power. Definition. Energy is the capacity to do work. Power is the rate at which work is done. Unit, joules or watt per second. Watt or joules per second. Symbol, E. P. Examples. Lamps used at 60-watt light bulb for 30 days which raised my electric. My car's battery can provide 500 at 12 volts which equals 6 kilowatt of power.